This is a CD4046 set up as a frequency multiplier. So I have here the signal coming in from that 555 timer, and it's operating at 44, 43 kilohertz. And now when I put the signal in through a frequency divider, put that to the clock, and that to a divide by 3 circuit. It gives me a multiply by 3 circuit. It's actually multiplying by 5, but that's breadboard stuff. I should have the reset on that pin. And that's a little more like it. That's a multiply by 3 circuit. It's a little jumpy, but that's because of the loose wires here. Let's make that a little more accurate. Okay, there it goes. And if I put these two together again, yep, that's about right. 60, 62. If I get away from it, I get less electromagnetic energy. And when I do multiply by 3 again, it jumps up by 3 times. So the way it's set up is this is on the left is a CD4046 set up with the signal in on pin 14 through that blue wire, and then the output pin, which is pin 4, is going into the clock of a CD4017 decade counter, and from the pin 3 output, this white wire that's right in front right here is going into the input of a phase comparator. That phase comparator on pin 3 of the CD4046 is tied to a low pass filter, which is that 1K resistor and the capacitor back there. And that signal is going back into pin 9 of the voltage control oscillator component of the CD4046. And that's the feedback loop. And by doing a divide by 3 using this counter here, in between the VCO output and the comparator input, you get essentially a multiply by 3 circuit, which, as you can see, is still stable at around 180. All right, now we can multiply frequencies. The only caveat with this is that it works better if the duty cycle is 50%. So that messes with the CD4046, especially if you have a greater than 60-70% duty cycle on the timer input. So works pretty well. Thanks for watching.